Welcome to myprojectbazaar.com. Here we are going to discuss about novel cascaded H-bridge multi-level inverter with a harmonic elimination. Inverters. The circuits which convert DC signal into an AC signal is called the inverter. Various types of inverters are available. It's a single phase inverter, single phase single level inverter, and multi-level inverter, multi-phase multi-level inverter. But the multi-level inverter is the one of the most recent advances in power electronics. The desired output voltage waveform is synthesized for several number of DC sources. This paper presents the two techniques for improving the quality of output voltage and efficiency. That is, the real-time implementation of PWM, that is selective harmonic elimination pulse width modulation technique in single phase inverter, is proposed. The disadvantages of this paper is the level of output voltage depends upon the number of DC sources and several number of carrier signals are used, and also the harmonics, that is third, fifth level harmonics that have been eliminated, but the higher order harmonics 11 and 13 which disturb the output voltage waveform. So in order to reduce those harmonics, we propose the system called GHNN based selective harmonic elimination technique. Generalized half-wave neural network is abbreviatedly generalized GHNN. The switching instant of PWM involves the solution of the equations. The entire problem is redrafted as an optimization problem. Using the optimization problem, it is solved by GHNN process. The 5, 7, 11, 13th order harmonics are eliminated by using this function. So the process of this PWM technique extended to the multi-level inverter. The 7-level inverter is implemented with PWM. The MATLAB simulation is carried out for various modulation indices. Next we are going to see the blocks used in our system. Modulation index, GHNN based switching instance, PWM generation, 7-level inverter, FFT analysis. Modulation index, it is the ratio of the DC input voltage to the fundamental output voltage. This modulation index, generally it is the ratio of reference signal to the carrier signal. So the amplitude of the reference signal and carrier signal has to be compared using this modulation index. Next block, GHNN based switching instance, an energy function which is formulated using the Fourier series representation. The different rate of change of energy function with respect to the time values are calculated, and they are all combinedly embedded in this block. Using this GHNN network, the repetitive iteration has to be performed to solve the switching instance. Here we are using the 7-level inverter. The switching instance corresponds to these elimination of harmonic 5, 7, 11, 13, and the keeping fundamental component as a high value, 5 switching instances are needed. Depending upon this condition, the switching instance of 5 is generated, and this is given to the PWM generation block. The PWM generation block consists of triangular wave generation and the accepted switching instance. The accepted switching instance compared with a triangular wave with an amplitude of 1.57 radian. Finally, the PWM wave is generated for the positive half cycle. This PWM wave is given to the transport block that converts the PWM pulses for the negative half cycle. Finally, the 7-level inverter is to be designed, and this PWM pulses are applied to this inverter. The FFT analysis also carried out for the output voltage waveform. That FFT shows the reduction of 5, 7, 11, 13 and fundamental component as a higher value. Next we are going to discuss about the running procedure of our proposed system. The proposed system consists of 3 major procedures: construction of PWM generation, 7-level inverter formation, parameter measurement, that is using FFT analysis. PWM generation. It receives the modulation indices and also ANFIS based switching instant generation carried out here. Finally, these switching instants are compared with the triangular wave of amplitude 1.57 radians. So the comparison provides the PWM pulses. First, the modulation indices is varied from 0 to 1 as a input. The initial values are given for Fourier series analysis expression, which is formed using rate of change of energy function. An energy function is formulated using the Fourier series representation of output voltage from the inverter. The switching instance obtained by using ANFIS based training with 100 number of epoch. The overall training done for 3000 number of iterations. The generalized half-wave neural network is constructed and ANFIS based switching instances are generated using these functions. And the switching instance compared with the triangular wave of amplitude 0 to 1.57 radians. The PWM pulses are generated for the positive half cycle, and this pulses delayed by 180 degree phase shift for the negative half cycle. These pulses are applied to the inverter circuit. 7-level inverter circuit consists of 3 number of subsystems of each 4 number of IGBT switches. They are all connected together. The positive half cycle pulses are applied to 1 to cross arm of the switches, and the negative half cycle pulses are applied to 3 to 4 cross arm of the switches. FFT analysis. This FFT analysis that shows the reduction of harmonics fundamental component to the required value. The number of cycles selected as 1. The fundamental frequency set it as 50 Hz. The display option in the FFT analysis block shows the 5, 7, 11, 13th order harmonic elimination and the fundamental component as high. The whole simulation repeated for 3 types of modulation indices: low range, medium range, high range. 0.247 selected as low range, 0.685 selected as medium range, 0.95 as high range. Using these range of modulation indices, the DC input voltage of 100 is applied to the cross arm of the switches, and the triangular wave amplitude of 0 to 1.57 with 20 milliseconds duration is generated, and they are pulsed and they are compared with the switching instant. Finally, the pulses are produced. These pulses applied to the inverter circuit, and FFT analysis shows the reduction of harmonics and fundamental component to the required value. Thank you.